Hi, everybody. I'm just going to carry on now with the notes that we have on electricity, but we're going to start by looking at a couple more electric circuits. So, question 12, and we'll start this session by looking at question 12 and question 13. Very similar to what we've seen before, but there is a slight sort of difficulty in working out the answers here. So I'll just talk you through, well, I'll work through the solution and hopefully you'll see it by the end how this works. Um, it's not, each of these is, I'm not even going to ask you to sort of spend time trying to figure the circuits out. You can just listen to me or just watch the video through. So in question 12, I'll just stop sharing there and copy in the diagram so you can see the visualizer, what we're looking at. Okay, so the circuit, as we've seen, 10 volt battery coming down, and this is a new arrangement of resistors we haven't seen up to now. Okay, and we just, so I'll just get the numbers, 50, 100, 200, and 200. And that's the 10 volt battery, 10 volt power supply. Right. So one of the things in the question, it says, for the circuit below, first identify those resistors which are in series and those which are in parallel. Now there's a clue there. It mentions those that are in series first. And remember what series is. The same current passing in turn through two or more resistors. And that's true of the 50 and the 100. They're in series with each other. Okay, so I can replace that resistor by a single resistor, which is equal to 150 ohms. So this circuit can be redrawn like this. That's now 150 ohms. That's 200, and that's 200 there. Okay, so now we have very clearly current comes to here, splits. Some of it goes that way, some of it goes that way, then it reunites. So these two must be in parallel. Okay, so again, we can work out it's 150 in parallel with 200. So therefore, 1 over R parallel, 1 over R1 plus 1 over R2 equals 1 over 150 plus 1 over 200. And as always, I've forgotten to bring my calculator with me. Uh, okay, so again, just to show you on the visualizer, if you're struggling with how to do these, I enter 150 and I have an x to the minus 1 button on my calculator. No, I need to I need to turn the calculator on for turn the calculator on. That's the first golden rule of maths. 150 x to the minus 1. That means 150 to the power minus 1 is the same as 1 over 150. Plus 200 x to the power minus 1 equals, and I get 0.01167. So 0.01167. Right, now that is 1 over R. In order to get the value of R then, I just hit the x to the minus 1 button again. Equals 85.71, 85.7 ohms. Okay, and now I can redraw this circuit into this circuit. 85.7 and 200 there. The current comes around here, goes through that resistor, then through that resistor. So we have a series circuit now. And so the total resistance is the sum of those two resistors, and that is 85.7 plus 200. So you get 285.7 ohms. Right, so total resistance of the circuit is the first thing we're asked to get. The current at the battery, part 2. What's the current at the battery? We'll apply Ohm's law to the whole circuit. Whole circuit. So we have for the whole circuit, Vt equals 10 volts. RT, which we've just worked out, is 285.7 ohms. And then I at the battery, the current in most of the circuit, is our question mark. Vt equals I RT. Vt over RT equals I. And you get 10 divided by 285.7. And that equals 0.035 amps. Nice round number. And just to remind you, going back to the original thing, that's the current flowing along there to that point. Now it splits here. We don't need to worry about that splitting just yet. Then reunite, and then we're back to the 0.035 amps all the way back to the negative of the battery. Part 3, the potential at W, Y, and Z. Now, part 3 is actually difficult to do at this stage, so we're actually going to skip ahead to, well, no. Okay, oh, I see now, yeah. The potential at W, Y, and Z. W is here. Y is here. And Z is here. Now, very easily, VW has to be 10. It's connected directly to the positive of the battery. And VZ has to be 0, because Z is connected to the negative of the battery. Vy is the one we need to work out. So if we know the potential there, we need to work out what potential difference is dropped over that resistance, which is equivalent of what potential difference is dropped across that resistance. So we'll apply Ohm's law to the 85.7 ohms resistor. So V equals IR. We know the current flowing is 0.035, and we know the resistance is 85.7. So therefore the potential drop there is 2.99, well, 3 volts. Almost exactly 3 volts. So there's a 3-volt drop between here and here, which means there's a 3-volt drop between there and there. So therefore, V at Y, sorry, I'm still on part 3. V at Y equals 10 minus 3, which equals 7 volts. Okay. 10 minus 3 is 7. Remember, so there's a drop minus 3 volts there. If you do the calculation out, you'll find that there's a 7-volt drop across that resistor. Calculate the current flowing in each of the resistors, part 4. Okay. Well, first of all, we know the current flowing in that resistor. It's simply the 0.035. The current at the battery is the same as the current flowing in that resistor. So we don't have to, if this was an exam question, you would say sort of I200 equals 0.035 amps, where I mean this 200 is the one at the side here. There is another I200, but we'll need to work out that separately. Okay, so Actually, I'll call that 200A and 200B. So 200B is 0.035. 200A, well, what's the potential difference across 200A? So we'll go through each resistor in turn. 200A, well, the potential difference across it, V200A equals 3 volts. Or 200A obviously is 200 ohms. So what is I 200A? Well, V equals IR. Therefore, V divided by R equals I. So 3 over 200 equals 0.015 amps. So that tells us what's going through that resistor. Now, if we move up here, the same current, so that's the current going there. The current going through these two resistors is the same, not the same as this one, but whatever current is going through the 50 is also going through the 100. Or we can think of it as just, if we go to this one, there's 3 volts drop between there and there. So there's 3 volts being dropped between there and there. That'll allow us to work out the current in that arm, which is the current in this arm. So 50 and 100 ohms. V 50 plus 100 equals 3 volts again. The resistance equals 150 in total. I equals what? Again, V over R equals I. 3 over 150 equals 0.02 amps. Now, if you take those two numbers and add them together, that plus that, you get this number here. Oh, sorry now. So remember what has happened there is the current coming along here. Some has gone that way and some has gone that way. So that current plus that current must equal the current out here. So we're finding that that's true. Sorry, those two added together bring me back to there. Right. That's the current flowing in each resistor. And finally, what's the potential at X? And this is the awkward part of this question. It does catch a lot of people out. And it is, it's not a type of question you'll be asked in an exam, just for the sake of stretching you a little bit and making you think about this. Really, what we want to know now, to work out the potential at X, we need to know what the potential difference across the 50 ohm resistor is. We know the current flowing through the 50 ohm resistor. So potential at X. So Vx is what we're trying to find here. So we need to calculate the potential difference across the 50 ohm resistor. Okay, so I50 we've just worked out is 0.02 amps, or is 50 ohms. So V equals what? The drop across. You can call it VWX if you want, the difference between the potential at W and the potential at X. So VWX equals IR equals 0.02 times 50, which equals 1 volt almost exactly. So VW equals 10 volts. Therefore, the potential at X, Vx, equals 10 minus the amount you drop as you go over the 50 ohm resistor, minus 1, so that is 9 volts. Remember, this Vx is potential at a point, a measure of the energy the electricity has at that point, whereas Vwx is a potential difference between 2 points. Okay, I'm going to pause the recording there before moving on to question 13. Okay, welcome back. I've just got the setup drawn for question 13, and it kind of can look a bit scary. I remember seeing this kind of setup when I was a student learning all this, and again, this would throw me. The idea of how do you cope with something going at an angle? What's that about? But really, the angle or anything like that is not what's important here. You have to figure out what's in series and what's in parallel. For some of you, this is easier than others. But remember, series, the same current passing into the turn through two resistors. Parallel, the current splits up, goes between the two roots, and then reunites. So the current has to split up and reunite. Okay, so if you look along this, some of you might be thinking, well, the 50 and the 100 are in series because they're in a line like that. But there's a branch here, so the same current, the current is flowing along there. Some of it's probably going that way and some of it's going that way. So it's not the same current. So these are not in series. Similarly for this one down to here, there's a current going along there, but then some might be going this way and some might be going that way. And so the first bit of progress we can make is by realizing that the current that goes along here, it splits at this point. Some goes that way and some goes that way, and then reunites at that point. So it splits some that way, and then reunites. So these two resistors are in parallel. And in some ways, it's handy to redraft the circuit. Every time you make a breakthrough like that, redraft the circuit. And really, simple wire doesn't change potential. And you can add in loads and loads of simple wires as long as you don't change the way the current flows, or you change you don't put a simple wire across a resistor or something like that. So I can redraft this like this to show that these are in parallel more clearly. So that's exactly the same circuit. I haven't changed anything. And now I can work it down. So I can now combine those two resistors together. 1 over 150 plus 1 over 120 equals, I'll just say this, 1 over R parallel equals that. So again, I'll turn my calculator on. 150 x to the minus 1 plus 120 x to the minus 1 equals. And I get 0.015. Again, that is not R parallel. That is 1 over R parallel. I hit the x to the minus 1 button again, and I get a value for R parallel of 66.67. Redraw the circuit. So I'm now replacing that parallel by a single resistor. And now I've got 100, and this is 66.67. Again, those two are in series. Therefore, the equivalent, I can redraw this circuit again as and this new resistor is found by adding those two together. They're in series, the same current along there and along there. So it's 166.67. This one, of course, what was it originally? 70. This one is still 70. And this one up here is 50. So now we have 70, 1 over R parallel equals 1 over 70 plus 1 over 166.67. That equals, again, clear here, 70 minus 1 plus 166.67 x to the minus 1 equals 0.0203. X to the minus 1 equals 49 point, basically 49, so R parallel, 49.3 ohms. So I can replace all of this by a single resistor, 49.3 ohms. My final redraw of the circuit then leaves me with this. This is 50 ohms, and this is 49.3 ohms. And so the total resistance of the circuit is 50.49.3, which equals 99.3 ohms. Okay, the question asks you to work out what current is flowing in the 150 ohm resistor. I could spend a bit of time on that, but really, I normally in class just say, look, you can work that out for yourself. You will not see something as complicated as this in an exam. So, but I just sort of, if you want to stretch yourself, you want to have a go at it, have a think about it. That's how those sort of circuits work. Always thinking, is it series? Is it parallel? Okay, so again, I'm going to pause there and we will resume continuing on with the notes. Hey everyone, I'm back again, and I've decided just to suggest that I'm going to go back to the question 13. I'm just going to kind of finish this class here by talking through the solution. Now, by all means, skip to the end of the video, to stop the video here if you think this is just beyond you or not something that you're interested in finding out about. It is much more complicated than anything you'll be asked to do in an exam. But it is the same procedures. I'm going to use the same procedures over and over again as we've used with the simpler circuits. There's nothing that bit more difficult. It is just a little bit more complexity than maybe you're used to with the other circuits. So we showed in the last class that the total resistance is, sorry, not the last class, but earlier in the video, total resistance is 99.3 ohms. I've just quickly worked through the rest of it here. I'll talk you through the answer and my solution. So we start off with the current. By the way, I do make mistakes, so hopefully this is correct. I hope I haven't made any sort of simple computational errors. So how do we figure out what the current is in the 150 ohm resistor, which is what the question asks us? Well, really, we have to work back from the start. We need to know, in order to work out the current in that thing, we need to know what the potential difference is across that resistor. Now, just to highlight here, we already know what the potential at that point is because it's linked directly back to the negative of the battery. We know the potential at every point along these wires is 0. So that's 0. So all we need to do, which is going to take a bit of calculation, but all we need to do is work out what the potential is there. Then we'll know the potential difference across that resistor, and then we use Ohm's law to work out what the current is. So we have to backtrack. We have to come, if I bring this down, we've got 15 volts, and we want to basically know what the drop in potential is across that resistor first, and that will allow us to get our first break point on this circuit. We know then what the potential is there. And we'll just take it bit by bit. So what's the potential difference across that resistor? Well, we know from this circuit here that the total resistance of the circuit is 99.3. So we can work out what the current in that whole circuit is. Current at the battery, Vt equals IRT, apply Ohm's law to the whole circuit. So Vt over RT is I. So the battery voltage is 15, the total resistance is 99.3. One over the other, it gives me 0.151 amps. So I know there's 0.151 amps going around that circuit. So therefore, I can work out what the potential difference across the 50 ohm resistor is by just using Ohm's law. So the potential difference across the 50 ohm resistor, as we just saw, is 7.55 volts. What that means is there's a drop in potential from the 15 volts going through here to point A. So the potential at point A is 7.45 volts. We take the 15 volts and we drop the 7.55 volts that was lost going through the 50 ohm resistor. So that leaves us with a potential here of 7.45 volts. Remember, we want to know what the potential is there, and then we'll know the potential difference across this resistor, and we'll get the current and all the rest of it. So we drop down to this circuit here, or even simpler than this, we drop down to this circuit here. We now know that that point there, these are all simple wires, so that's 7.45 volts, and this is 0 volts here. So we now know that the potential difference across that resistor is 7.45 volts. Okay, so the potential difference across that resistor is 7.45 volts. The resistance is obviously 166.67 there. What's the current? And the current you get is 0.0447. So along this arm, 0.0447 goes to there, and then it splits. But that 0.0447 going along there allows us to work out what the drop in potential across this is. So the potential difference across a 100 ohm resistor is that current times the size of the resistance, and we get 4.77 volts. We started 7.45, we drop 4.47, so we can figure out what the potential difference is there, or what the potential is there. Potential at that point there is 2.98. And now with that potential there, we know the potential difference across the 150 ohm resistor, so that we don't need to go any further. So that's the 2.98 volts. We know the resistance, we can work out the current. So V150 is 2.198. The value of R is 150. So what's the current flowing there? We'll use Ohm's law as always. Put the numbers in, and you get 0.0199. In the previous sort of calculation of this, I had 0.02, but it was got with a slight mistake in it. Okay, so if you watched this far, well done. I hope that made sense to you. I'll be hoping in the next few days to record videos to cover to the rest of the module. So expect to see more materials up in the next few days. Thanks for your attention, and I'll stop there.